Ahoy, governor! You fancy a chat about some parallel lines? Well, Bob's your uncle, I'd be chuffed to bits. Pull up a chair, pour some tea, grab some crumpets, let's get to it. Class 11 of Unit 4, Equations of Parallel Lines. Joke's on you, I'm British now. I'm kidding, I've been British the whole time. And what if I stayed British this whole video? I'm not going to do that. Hi! In algebra, more often than not, we focus our attention on one line at a time. But out in the real world, if we find some lines, it's way more likely we're going to encounter two or more of them at the same time. And often, we'll find that they interact with each other in some pretty interesting ways. For pairs of lines, we're going to focus on two interesting interactions between them, the first of which we'll talk about today, when two lines are parallel to each other. Now, hopefully you know what it means for two lines to be parallel. I'd like you on an XY plane to sketch a pair of lines that are parallel to each other. We want to make some observations about how something about their equations builds in this particular criteria, this definition of parallelism. If you sketch two parallel lines for me, make an observation, hopefully, about what seems to be the case that allows them to meet that criteria for whatever parallel means. Take a risk, take a chance, who cares? Try something out, see what sticks. Go ahead. Alrighty, well, let's talk about some parallel lines. First of all, let's establish a working definition. If two lines are parallel, the symbol that we use, because mathematicians love a good symbol, notice that two lines that are parallel, by definition, do not intersect. They never cross each other. The cool thing about the word parallel is that you even notice there's a pair of parallel lines kind of right there, that double L. It turns out that that double L in the word parallel is exactly the symbol we'll use to indicate that two lines are parallel. So say I have a line L1 and a line L2, again line 1 and line 2 with our subscript notation. The symbol for indicating that these two lines are parallel, I would say that L sub 1 is parallel to L sub 2, just like that. In order for two lines to be parallel, let's establish a formal definition here. The first thing that's important about them, and this criteria will make more sense once you get into geometry, first of all, the lines need to be in the same plane. So it's totally possible out in 3D, you can find two lines that aren't on the same flat plane that don't intersect. In order to be parallel, they in fact need to be on the same flat plane. Two lines that don't meet this criteria but don't intersect, if you're interested, are called skew lines, S-K-E-W. But you don't need to know that for now. We're just talking about parallels. But importantly, once they're in the same plane, the only way for them to be parallel is if they do not intersect. So we'll say that two lines that are parallel do not intersect each other at any point on the lines, which means no matter how far I go out, I'm going to try my best to draw a pair of parallel lines here. My two lines will never cross each other, no matter how far we extend. Hopefully, if you sketch a pair of lines that actually are parallel, you'll notice something about them. Well, in order for them to never intersect, notice that my lines are oriented exactly the same way in space. Another way to say that is that these lines have the same steepness, right? They are both increasing in this case at the same rate. What that should hopefully tell you about lines that are parallel is that lines that are parallel have the same slope. If their steepness is the same, the rate at which they're increasing, their rate of change is identical. Their slopes are the same. So the thing that we'll notice here is that parallel lines have the same slope. So if, for example, I have two lines L sub 1 with a slope of m sub 1 and L sub 2 with a slope of n sub 2, algebraically, what we'll say is that in order for these lines to be parallel, in other words, L sub 1 is parallel to L sub 2, line 1 is parallel to line 2, if and only if, so that's just a fancy way to say the only way for that to be true is if their slopes are equal, algebraically, right? M sub 1 would need to be equal to M sub 2. What you'll notice, though, is that the points on these lines are unique. There is no way I can have a point on one line than on the other. So, for example, if y equals mx plus b is the equation of my line, I know that these m values are going to have to be the same. However, if they have different points, for example, where they cross the y-intercept is totally different. So while their m values will be the same because they are different lines, right, their b values, in this case their y-intercepts, and in fact any points on the line, right, they cannot be the same. They have to be different. Cool. With this idea in mind, let's say, for example, that I have two lines. One of them passes through the point 1, 1 and 0, 2. The other passes through the points 0, 12 and 5, 7. I want to show that these lines are parallel to each other, which means I need to determine that their slopes are the same, but that their y-intercepts are different. Take a minute, pause the video, show me that these two lines meet those two criteria. Go ahead. Alrighty, so I need to first show that their slopes are the same. Well, how could I find the slope of this line? Well, I know that slope is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I can use my slope formula. Let's say here, doesn't matter my order, that I call these points x1, y1, and x2, y2 like so. All I need to do is substitute in. Well, y2 here is 2 minus y1 is 1. x2 is 0 minus 1 for x1. 2 minus 1 gives me positive 1. 0 minus 1 gives me negative 1. 1 over negative 1. This line has a slope of negative 1. For this guy, same idea, right? Doesn't really matter which one. Maybe I'll say this guy's my x1, y1. This guy's my x2, y2. All I need to do to find slope is substitute into my slope formula. So I'll say y2 of 7 minus y1 of 12 over x2 of 5 minus x1 of 0. 7 minus 12 is negative 5. 5 minus 0 is 5. Negative 5 divided by 5 is negative 1. So their slopes are the same. Are their y-intercepts different? Well, yeah. Notice to find the y-intercept, what do I need to do? 5, 4, 3, 2, 1. Well, to find the y-intercept, x needs to be equal to 0. So that tells me here that this first line has a y-intercept of 2, whereas this second line has a y-intercept of 12. 2 and 12 are, of course, not the same. The y-intercepts are different. So yes, indeed, these two lines are parallel to each other. Fantastic. Combining all of this with our prior knowledge, knowing what makes two lines parallel, we should now be able to find equations for parallel lines. Say, for example, that I have a line that passes through the origin and is parallel to this line y equals negative x plus 2/3. I want to find its equation. So take 30 seconds in game plan here. Don't need to write anything down, but think strategically. How could you use this information, the fact that you've got the origin as a point and a parallel line to your advantage, to build your equation? Pause the video, see what you come up with. Go ahead. Okay. Well, again, if I want to find an equation of my line, my best bet is probably to use point-slope form. So we're going to call this step 2 of our strategy, right? I know that I eventually want to be able to use point-slope to find the equation of my line. Altogether, point-slope is y minus y1 equals m parentheses x minus x1. So this is what I want to get to. In order to get there, I need a point and a slope. Well, notice here, I've got a point in the form of the origin. The origin is 0, 0. I can call this my x1, y1. And I know that my line is parallel to y equals negative x plus 2/3, which means that they have the same slope. Well, what's the slope of y equals negative x plus 2/3? Well, notice it's in slope-intercept form, y equals mx plus b. The coefficient of x, here negative 1, is equal to our value of m. So my line has the same slope as that line, which means that negative 1 is going to need to be my slope. Cool. With all of this in mind, all I've got to do is substitute in. So my first move is to start by finding the slope of our parallel line. Knowing that my line will have the same slope, if I can find that guy's slope, all I've got to do is substitute into point slope form. So I know here that y minus y1, which is 0, is equal to m, which we've identified as -1, parentheses x minus x1 is 0. Well, x minus 0, that's just x. So I've got -1 times x on the right side, which is -x. Y minus 0 on the left is just y. Would you look at that? Y equals -x needs to be the equation of my line. Fantastic. Now that you've got the fundamental idea down, let's do a little bit more practice. So here, I've got a line. It passes through the point -5, 0. It is parallel to this guy, y equals -7/5 x plus 450. Let's find the equation of our line. Take 2 minutes, pause the video, go ahead. Have fun. All right, you little rascal, let's bring it back in. So, I know here that I eventually want to get to my point slope form. So I'll even write it down here, right? I know that I want to use y minus y1 equals m, parentheses x, minus x1 if I'm going to build the equation of my line. I know here the point -5, 0 is on my graph. This is in fact the what of my graph? 5, 4, 3, 2, 1. Very good. It's the x-intercept, right? Y is equal to 0. So when y is equal to 0, we get our x-intercept. So I've got my x-intercept. It's parallel to this guy here. Again, parallel lines we know have the same slope. So the slope of my line should be the same as the slope of this line. This guy has a slope of -7/5. So I know that my line should have a slope of -7/5. All I've got to do is substitute everything into place. So x minus -5 on the right side times -7/5 is equal to y minus y1, which is 0. Let's simplify. So I got y minus 0, which is just y, is equal to -7/5 times x plus 5, right? Minus a negative becomes a positive. All I've got to do now is distribute. This should be y is equal to -7/5 x. And if you don't believe me, feel free to fact check me. But -7/5 times +5, first of all, positive times a negative is a negative. Then I have 7 divided by 5 and multiplying by 5. Our 5s are actually going to cancel out. It's just going to leave us with -7. There you go. There's the equation of our line. Cool. So in this form, our slope is obvious, but it won't always be the case. Let me show you 2 variations of this problem. First of all, I might have a line that passes through a point, and it's parallel to a line that's in standard form. Another variation, I could tell you that my parallel line passes through 2 points. Either way, we want to find the slope of our parallel line to use to our advantage. Give yourself 3 minutes. Try each of these out. Take a risk, take a chance, see what you come up with. Go ahead. Okay, so here, I know I've got a point, 0, 5. We'll call this our x1, y1. And then I've got a parallel line in the form of 3x plus 2y equals 1. There are a couple of ways to find the slope of this line. I think the easiest way is to rewrite it in y equals mx plus b, our slope-intercept form. So, wisest move to make here is to get y by itself. Let's start by subtracting 3x from both sides. I know that 2y is equal to -3x plus 1. Divide both sides of our equation by 2 to get y by itself. That tells me here that y is equal to -3/2 x plus 1/2. Now, of course, the 1/2 doesn't matter, but I know that the slope of this line is -3/2. And since my line is parallel to this guy, I know that the slope of my line must be the same. All I've got to do now is take my slope-intercept form. Point slope form. Silly Mr. Villel. So I'm going to take y minus y1 equals m times parentheses x minus x1. I know here, substituting in, that y minus my y1 value of 5 is equal to my slope, which is the same as my parallel line, times x minus x1, which is 0. Of course, x minus 0, this is just x. So I have y minus 5 is equal to negative 3/2 x. To get y by itself, I'm going to add 5 to both sides. So that leaves me with y equals negative 3/2 x plus 5. Magnificent. Now you might even have noticed there's a simpler way. I know that 0, 5 is in fact the y-intercept. So if you were interested, you could from this value say that b is equal to 5. Notice that the slope is negative 3/2. So negative 3/2 x plus 5 would need to be your equation. So there's another way that you could have solved this problem. If you wanted to use point slope though, be my guest. I like it. It's my comfort formula. Okay, now I've got negative 4, 7. I'm parallel to the line through negative 3, 4, and 5, negative 2. So again, all I need is to find the slope of this line. It doesn't matter what the equation is as long as I have its slope. Well, to find the slope of this line, let's use my slope formula. So slope is y2 minus y1 over x2 minus x1. I know here, if I go through and label my points, maybe I'll call this guy my x1, y1, this guy my x2, y2. Again, the order doesn't matter. But if I take y2 of negative 2 minus y1 of 4 over x2 of 5 minus x1 of negative 3, that should give me my slope. Well, negative 2 minus 4 is negative 6. 5 minus negative 3 becomes 5 plus 3. Negative 6 over 5 plus 3. 5 plus 3 is equivalent to 8. Negative 6 over 8 reduces to negative 3/4. All I've got to do now is use my point. So I'm going to call this guy my x1, y1. I know that my slope of negative 3/4 is going to be the same as my parallel line. So using my point slope form, I know that y minus y1 is equal to m parentheses x minus x1. All I've got to do is substitute in and solve for y. So I know y minus y1, which is 7, is equal to negative 3/4 x minus negative 4. I'm just going to skip my step here and write that as x plus 4. On the right side, I've got some distribution I can do. I know that y minus 7 is equal to negative 3/4 x. Negative 3/4 times positive 4. Feel free to fact check me. That should be equal to negative 3. And then all I've got to do to get y by itself is add 7 to both sides. In this case, y is going to be equal to negative 3/4 x plus 4. Fantastic! You now know how to find the equation of a parallel line. Congratulations! Next time we see each other, we're going to talk about perpendicular lines, but this isn't next time, this is this time. So until next time, take care, be well, get some sleep, be good, and I'll see you when I see you. Goodbye!